In this module, we will cover the communications system of the aircraft. We will start out with an overview of the system. Next, we will discuss the various components of the system, including the VHF radios, the Remote Control Audio Unit, or RCAU, the audio control panel, the interphone system, and the PA system. Finally, you will learn how to tune the radios. The communications system provides for several modes of communication, including aircraft-to-ground communication, interphone communication between the flight crew, cabin crew, and ground crew, a passenger address or PA system, and automatic warning systems that alert the flight crew. The interphone allows communication between the flight crew, cabin crew, and ground crew through certain ground stations outside the aircraft. These ground stations are located in the hydraulic bay, located in the left main gear fairing, the ground electrical power receptacle, and the unpressurized bay, located in the aft fuselage section. The flight crew communication system primarily consists of two audio control panels, located on the center pedestal, and the Remote Control Audio Unit, or RCAU. The aircraft incorporates two transponders. Optional communication equipment consists of ATRs, or Aircraft Communication Addressing and Reporting System, cell call, or selective calling, and an HF system. ATRs is a digital data link system used for transmitting short, simple messages between an aircraft and a ground station, via satellite or radio. The Radio Management System, or RMS, manages the radio communication, radio navigation, and the TCAS transponder system through multifunction control display units, or MCDUs, multifunction control panels, or MCPs, and virtual control panels, or VCPs. The Radio Management Application, or RMA, manages the radio navigation and communication equipment, and displays communication and navigation settings on the different displays. The Radio Management System incorporates two redundant RMAs, hosted in display units 2 and 4. The aircraft has two VHF transceivers, VHF-1 and VHF-2, which are used for receiving and transmitting. The captain's transceiver, VHF-1, is powered by the DC emergency bus. Therefore, even in the event both generators are lost, the captain's transceiver will remain operational until the emergency battery runs down. The first officer's transceiver, VHF-2, is powered by DC bus 2. Each transceiver is connected to an associated antenna, and the radio management application. The VHF radios can be tuned by either the multifunction control display units, or by the multifunction control panels. The VHF radio frequencies are displayed on the virtual control panel, on the multifunction display. The heart of the communications system is the Remote Control Audio Unit, or RCAU. The RCAU processes audio signals from the radios, the interphone, as well as alerts from the flight warning system. Then it directs those audio signals to their corresponding outlet, such as the loudspeaker or the headset. The RCAU consists of two electronic processing boards. If an RCAU processor board loses power or fails, an amber fault caption will illuminate on the related Audio 1 or Audio 2 select push button. These push buttons are located on the far side of the instrument panel, in front of each crew member. Releasing this push button bypasses the failed processor board, so that only the associated communications radio is available. For example, if the captain releases the Audio 1 select button, only VHF-1 will be available. In addition, the PA, interphone, and other VHF radio are no longer available on the captain's side. In either case, the audio on the affected side can only be adjusted by the associated loudspeaker volume control. Each pilot has an audio control panel, or ACP, which is used to make communication and navigation selections. These panels are located in between the pilots, on the center console. The ACP provides the ability to transmit through the VHF radios, the interphone, or the HF radios. An additional selection enables the crew to make PAs from the flight deck. In order to transmit through a given source, the desired transmission key is pressed in. Once a transmission key is pressed in, it illuminates white. Only one key can be selected at a time. Selection of a transmission key automatically deselects any previously selected mode. Once a communication mode has been selected, transmissions are made through the boom microphone. One of the following methods is used to transmit through the selected mode. Place the INT rad switch on the ACP to the rad position. Or squeeze the push-to-talk selector on the outboard side of each control wheel. The hand microphone incorporates a push-to-talk button as well. The captain also has a push-to-talk switch on the nose wheel steering hand wheel. There is also a microphone built into the oxygen mask. When the mask is pulled out of its receptacle, the active microphone is automatically transferred from the boom microphone to the oxygen mask microphone. Transmissions are made through the oxygen mask microphone, using one of the methods described previously. The transmission through the oxygen mask or boom microphone is controlled by the INT rad switch on the ACP. It has 3 positions. The forward position is labeled INT for interphone. In this position, the associated crew member's boom or oxygen microphone will be hot. This allows the flight deck crew members to communicate through the interphone system, without having to press a transmit button. However, transmission through a system selected by a transmission key requires the use of one of the push-to-talk buttons described previously. The middle, neutral position turns off the hot microphone. When this position is selected, a push-to-talk button will have to be used for each transmission, including interphone communication between crew members. The aft position is labeled red for radio. This selection is spring-loaded and should be held down while a transmission is being made. This position is used for radio communication between the flight crew and ground stations. The control wheel push-to-talk trigger button can be pushed forward for interphone communication, or pulled aft for radio communication. The forward position would be used if the INT rad switch is selected to the neutral position. The neutral position is sometimes useful to cut down on static noise through the headset channels. If this were the case, you would push forward on the control wheel push-to-talk button to talk with the other crew member. The reception volume of the various communication modes is adjusted by the volume control knobs, located under the transmission keys. Navigation source identifiers can be heard for VORILS, DME, ADF, and marker beacons. Navigation stations often broadcast their identification code, using both Morse code and voice mode. The Morse code part can be filtered out by pressing the voice-only key. The key illuminates amber when it's pressed in. There are 2 overhead speakers in the flight deck. The volume of these speakers is controlled by an associated loudspeaker volume control knob. The loudspeaker is muted during transmissions, to avoid any audio feedback through the system. It should be noted that the loudspeaker volume control knob does not change the volume of any oral alerts. An interphone system provides communication between the flight crew, cabin crew, and the ground crew. Calls to the cockpit from the flight attendant, however, are indicated on the call's overhead panel. To call the flight attendant, a pilot presses the attendant push button on the call's panel. The call will be accompanied by a chime in the passenger cabin. The flight attendant can then check the flight attendant panel to find out where the call is coming from. The flight attendant can call the flight crew using the attendant handset. In this case, the blue call caption illuminates in the attendant push button on the call's panel, and a chime sounds in the flight deck. To speak to the flight attendant, a pilot presses the interphone transmission key on the ACP, and then uses a push-to-talk button. When there is an emergency call from the flight attendant to the flight deck, an emergency amber light illuminates on the call's panel. Also, a chime will sound to let the flight deck crew know there is an emergency in the cabin. Calls to and from mechanics work similarly through the mechanic button on the call's panel. When the mechanic button is pressed, a horn sounds in the nose gear bay to get the mechanic's attention. The mechanic can then press the call push button next to the headset jack in the gear well to call the flight deck. This will cause the blue call caption to illuminate in the mechanic push button on the call's panel. As before, a chime will sound to alert the crew. The flight crew can then transmit to the mechanic by pressing the interphone transmission key on the ACP and then using a push-to-talk button. The flight and cabin crew can make passenger announcements via the passenger address, or PA system. Whether through the flight attendant station or the flight deck, all PA calls are amplified through loudspeakers located in the cabin, galley and lavatory. In the flight deck, PAs made by the flight attendants can be heard by selecting the PA volume control knob. PAs from the flight deck are made by selecting the PA transmission key and using one of the push-to-talk buttons. The flight attendant can make announcements with the handset by depressing the PA push button above the handset cradle. The PA system generates a single chime in the cabin. You probably noticed by now that there are no radio tuning units in the flight deck. The radios are actually tuned through the Virtual Control Panel, or VCP, which is displayed in the bottom part of the multifunction display, or MFD. To display the VCP on the MFD, you need to select one of the buttons on the multifunction control panel, or MCP. There are two MCPs, located on the aft section of the center pedestal. Click on the COM push button to display the VCP communications page. Once the VCP is displayed, you can select the desired radio. The selections are VHF or HF. The four arrow keys are used to move the cursor around the VCP display. If VHF is selected, you will be able to set the active and standby frequency on the two VHF radios. The active frequency is the one currently in use. The standby and active frequencies are swapped by selecting the soft button in between the frequency windows. A frequency is set by using the numeric buttons on the MCP. Radios can also be tuned using the Multifunction Control Display Unit, or MCDU. The MCDU enables the crew to interface with the Flight Management System, the ATRs, the Radio Management System, the Aircraft Condition Monitoring System, and the Central Maintenance System. The Radio Management System is accessed by pressing the RMS button on the MCDU. Click on the RMS button to continue. This will display the communication page on the MCDU screen. This page will display the selected frequency for the VHF and HF radios. There are also options to control the transponders and the TCAS system. Click on the line select key adjacent to VHF1 to set the frequencies for VHF1. The VHF1 page displays the active and standby frequencies for Radio 1. Note that this page also allows you to control the squelch of the radio, something that you could not do with the VCP. A frequency is changed by typing in the desired frequency in the scratch pad, and then selecting the desired line select key. Click on line select key 1R to set the standby frequency to the value set in the scratch pad. A standby frequency is made active by pressing the R1 line select key. The HF radios are controlled using the MCDU in the same fashion. The HF page also provides control of the modulation mode, as well as the squelch and power level. It was mentioned previously that some radio parameters can be set using the MCDU only. The table on this screen shows the parameters you can control through the VCP and MCDU. This concludes the communications module.